Dagster Deep Dive. We're going to give people a few minutes to join here. And it's the end of August right now, the end of summer, fun's over. I don't know whether that feeling of the end is near is from my time being a school kid and summer vacation being over, or whether it's the ancestral memory of being a farmer where the winter's coming, the harvest will be soon. So I don't know, but I predict a bountiful harvest this year. I don't know about you guys, but
yeah, sure. I think there will be a bountiful harvest. Yeah.
Said Noonan.
I don't know. I saw the neighborhood kitty's 8 years old. He was just moping around the neighborhood yesterday with school coming up. Yeah, I think that's a predictor of good yields for our crops this year.
Relatable.
Oh, yes. So everybody, this will be recorded, and we'll share the recording 2 hours after the event. We're also using a new platform for our webinars. It's going to be a lot more engaging, and I'm excited to see how everybody enjoys it. But we'll give everybody another minute here. Oh, also, if you have questions, please put them in the Q&A. I see that someone has already asked one. We will answer them after the presentation. And yeah, there's this upvoting mechanic, so that allows us to sift through the priority ones. But I'm really happy the amount of people that joins are Dagster running Dagster Deep Dives. I unfortunately, funny story with the last one, I wasn't able to make it because some bozo in my neighborhood ran into a power line, and I was out of power for 3 hours and missed one of our best webinars ever. But I'm happy to be here at this one.
Mind you, this was my first webinar that we had ever done, and Noonan 10 to 15 minutes prior had said, "Hey, I'm not getting on to help you today." I was freaking out, but it ended up being a good time. But I'm glad you're here today, bud.
Yeah, I'm glad we can talk about streaming, because that is something that comes up in the community a lot. It's, hey, I have these different pipelines, or we need to incorporate some streaming data set into our data platform. And we have some documentation on how to do that, but I think it'll be really beneficial for everybody to walk through a semi-complex implementation and actually see the code, the architecture, and the decisions behind it.
Yeah, and in the chat, I would be curious to hear for anybody watching how they're currently utilizing streaming, or how they might be incorporating Dagster into a streaming pipeline, just because this is our first foray into doing this internally, and I would just be curious to hear how other people are handling it on their end.
All right, I think we got enough of a quorum here, gentlemen. Roach, you want to kick it off?
Yeah, that sounds great. Hey, everybody. I'm Nick Roach. I'm Dagster's internal data engineer. Welcome to another Dagster Running Dagster presentation. If you were here for the last one, welcome back. If you're new, welcome. Today, we're diving into our internal data platform. I'll walk you through a specific problem we face processing some high-volume data, how we're currently handling that problem, and more importantly, how we're planning to use streaming to better solve this problem for the future. So I've got Colton and Alex here with me today. If you have any questions during the presentation, just ping the chat. They'll bring it to me. We can go through them as we talk, or we can save them for the end, whatever we feel feels good for the flow. As for the structure of the presentation, I'll briefly talk about what Dagster Open Platform is and how you can use it to learn about Dagster. I'll cover the current pipeline, the current state of things, the challenges we're facing with that current pipeline, and then we'll explore this new streaming solution that we're testing out and how it works and how you might be able to try something similar. Then we'll actually walk through that pipeline in Dagster. I'll go through the code, and then we'll go through a Q&A if you guys have any questions, but don't hesitate to drop stuff in the chat as we go. I'd love to make this sort of a back and forth as we go through it. So with that, I want to briefly touch on Dagster Open Platform because it sits at the foundation of this whole project. So what is it? First of all, it's our internal data platform, right? It powers all of our in-house analytics, consuming all of these upstream data sources. Dagster acts as the engine for all of those pipelines, from ingestion all the way to reporting. Second, it is a testing environment for experimental features. When product comes to us with components or some new thing they want us to try out, we get first dibs on testing out those features, giving feedback before they make it to you to try out. Most importantly, it is an open source code base that you can go on GitHub right now, access, and learn about how we use Dagster internally. It gives you a real production example of Dagster running in a real production environment that you yourself can learn from as a user of Dagster. So if you want more details on Dagster Open Platform, I'd recommend checking out the previous webinar. I spoke in a little bit more detail there. Obviously, go check out the GitHub page or reach out to any of us if you have any more questions about Dagster Open Platform. But one of the pipelines that we manage with Dagster Open Platform is the ingestion of this event data from Dagster Plus. And I want to dive into that data and talk about it and how we currently ingest it. So first of all, we have all of these organizations that manage their data platforms with Dagster Plus, right? All of these organizations generate some form of activity. They materialize assets, they kick off runs, they perform asset checks. Some of those checks fail, some materializations fail, runs succeed. All these events get logged in this event table in a Postgres database that powers the Dagster product, the UI, the backend, all that stuff, right? This event data serves two purposes. Obviously, it powers the Dagster platform. That's number one and most important. But it's also like a massive value to us as a data product for the internal data team. It tells us how people are using the Dagster product. This event data is easily our most used data resource at Dagster. It powers our billing pipeline. It drives our Dagster Insights product. It's used in all of our in-house analytics workflows to help us understand the behavior of our customers. So how are we currently getting to this data, right? How are we getting it from Postgres and bringing it down into our data warehouse so that we have access to it and can take advantage of it, right? Right now it works like this. The data starts in Postgres, as I mentioned, and then we use a tool called Sling to pull that Postgres database every 5 minutes. Sling grabs all the events that have landed since the last time we pulled, since the last event that was landed in the data warehouse, brings them in, and then we model those events downstream within our data warehouse. It's essentially this rapid polling process where we're constantly asking that Postgres database, hey, what's happened since the last time you asked for any data, right? Now, not a terrible solution, right? But as you can probably imagine, that comes with some significant problems. First, that regular polling is putting unnecessary stress on the Postgres database. If there's a better way that doesn't involve us hitting that database constantly, that application DB, then we would prefer to do that, right? To take a little bit of load off of that application database. Second, if we fall behind collecting from that Postgres database, we have to catch up. Let's say the connection goes down for a few hours. Now we have to play catch up and collect all of those events generated during that downtime. And in these 5-minute intervals, we can see hundreds of thousands of events, and that translates to millions per hour, right? So falling behind is a pretty big deal. We have to catch back up after we've lost all that time. Third, we've started sharding our Postgres database. That is, we've spread the loadout of this data into multiple Postgres databases, right? And that requires us to make multiple Postgres database connections, right? These multiple databases can generate events that we need to pull into our data platform. And so ideally, we would just land all those events in one location that we can get to instead of having to create a new Postgres connection every time a new shard is created. And then lastly, we don't have a lot of visibility into which events are being ingested during any given pipeline execution, right? We're just grabbing whatever Postgres has for us since our last pull. It could be the last 5 minutes worth of data, or if maybe there was a little bit of downtime, it could be the last 2 hours worth of data. Ideally, we have this data partitioned so that we know which data we're pulling in for a given execution of that window or that pipeline, right? Rather than just give me whatever has been generated since last time, actually tell me what set of data am I pulling in? Am I pulling in the last hour? Am I pulling in the last day, et cetera? Just so we have a little bit more visibility into that pipeline. So before we dive into this new solution, I want to do a quick detour into streaming and some of the architecture that's been set up for us that allows us to move into this new solution. So first of all, what is streaming data? You'll probably find 5 different answers if you search 5 different websites, but effectively, when data is streamed, it's processed in real time and continuously as that data is being generated. as opposed to batch processing, where we're processing data in sort of groups or batches, usually at some hourly or daily cadence. And thanks to our infrastructure team, we now have a way to stream process our event data through a Kafka producer that they have set up. And for any of you unfamiliar, Kafka is a tool that handles the production and consumption of event data. It's a common tool used for stream processing. You create producers that will emit events and consumers that can consume and process those events, right? And in our case, every time an event is generated by a Dagster organization, that event is emitted by that Kafka producer. And then we on the data team can consume those events and process them in real time however we want to. And in this case, we're going to use a tool called Flink that allows us to consume that Kafka stream, take in that data and process it. And in this case, we're going to land those files, that data in S3 as Parquet files, and then batch process that data into our warehouse. So this is a hybrid process of streaming the data into a place that we can get a hold of, and then we can batch process it however we want to get that observability, to get those time windows that we were talking about. So what makes this better than what we're doing right now? Big problem that it solves is we don't have to directly connect to Postgres anymore, right? We're just hooking up to S3. There's none of this, oh no, our DB connection dropped, all that stuff. No, just give me the stuff in the S3 bucket and we're good to go, right? There's no longer this catch-up issue, right? If Flink disconnects from Kafka, it'll just pick up where it left off. And then when the data lands in S3, we'll collect it when that batch completes. Database shards are no longer an issue. All events will be written to the same location in S3, regardless of which database they would have been in originally. And then lastly, we can easily monitor the steps in this pipeline and track which events are landing in the warehouse. We can partition that S3 bucket however we want to and land that data in those partitions. So we can say, hey, only give me hour X or only give me the last 2 hours worth of data. And now Dagster can see all of that stuff. And we'll show you exactly how Dagster will play a pretty big role in the observability of this pipeline in just a minute. So I'll give you a little high-level sort of architecture diagram of the solution, and then we'll dive into how Dagster plays into it. It's actually a pretty straightforward pipeline, right? As we mentioned, we've got this Kafka producer that is emitting that data. And then Flink, that cute little squirrel in the middle there, is going to pick up that event data and land it as partitioned data, hourly partitioned data in S3. Now, I'll show you the code for how this works at the end. I won't leave that up to the imagination, but that's effectively all it's doing. Flink is collecting these events and then partitioning the data out by hour into S3 so that we can collect it on the other side using what is called a Snowflake stage, an external Snowflake stage that just allows Snowflake to hook into S3. And then on top of that, a Snowflake external table, which just allows us to select easily from that external stage. So there's not much going on here, right? It's not a super complex pipeline. We've got this sort of hybrid process of streaming data into S3 and then batch processing it into Snowflake. So how does Dagster play into this? How do we allow Dagster to integrate into this pipeline? First of all, Dagster is going to use sensors to trigger new runs of this pipeline when data arrives in S3. So Dagster sensors have this concept of a cursor where we can keep track of state, right? And in this case, our cursor is the last thing that landed in S3, that last directory that landed in S3. So the sensor will check, did a new directory arrive? If yes, okay, great. Update that cursor and let's refresh the downstream dependent assets, that external stage and external table, and pull in that new data into Snowflake. And then now that's great, but what happens if that data doesn't arrive, right? Like the sensor's only going to kick off if it sees that new data, right? If Kafka goes down or Flink goes down or there's some other disconnect, Dagster can help us there too. We can alert on that data if it doesn't land within a certain amount of time, and we can receive some sort of Slack, email, whatever to notify us that the data didn't make it, right? So in this case, Dagster's acting as this sort of manager of the flow from S3 into Snowflake. It's checking to make sure Flink is doing its job, but it's not really telling Flink what to do, right? It's simply ensuring that Flink is landing that data in S3 as expected. And if it doesn't work, we'll get notified, we'll resolve the problem. If the data does land, great. Dagster kicks off a run and that pulls the data into Snowflake where we can model it downstream. And then lastly, one of my favorite parts of this pipeline is that we get to use Dagster components to manage these Snowflake objects. For anyone not familiar, components are, I like to think of components as like infrastructure as code for our data platform. It's a YAML-based DSL that allows us to declaratively build Dagster assets. So in this case, I used components to define all the parameters that Snowflake needs to build out that external Snowflake stage and that external table. I put it all in a YAML configuration, and then I build a custom component that accepts that YAML and builds out those Snowflake objects, right? So on the first run, it'll build out those objects, and then on subsequent runs, it'll do that refresh that we're talking about, right? So that materialization of these two assets is the refresh of that Snowflake stage and that Snowflake table, right? And it was easy to set up with components. I'd actually already had this custom component set up, right? And so adding a little bit of YAML config to just hook into an S3 bucket that we were landing this data in was no big deal. I'd highly recommend checking into components if you haven't already. We have plenty of content out there, so definitely check it out. That's the streaming solution in a nutshell. I want to walk through the pipeline a little bit, show you what it looks like in Dagster, and then I'll show you a little bit of code. I don't know if we have any questions before we jump into that. Noonan, Colton, do you want to talk a little bit before we jump in? Any thoughts?
Yeah, there have been some good questions. I actually am curious if you know about this or if it's something more on the platform team, but I believe Kafka is becoming like the source of truth, and like the application is reading and writing to the Kafka topic. What is happening to the existing events database?
Yeah, so it's a good question. I think the plan eventually, I think right now there's this parallel write happening. It's probably best to bring in our platform team to talk about this a little bit more, but there's this parallel write happening to both the database and to the Kafka stream right now. But I think eventually the plan is to move Kafka a little bit further up, and it will still write that data to the database, the Postgres database, but Kafka will be the thing actually doing that writing, right? Because you still need the data in Postgres for Dagster to do things like let the user know if a run failed or if a materialization succeeded, right? Dagster still needs that information, so you want to land it in Postgres. But this Kafka stream allows things like our real-time insights product to exist, where we can hook into a live stream of that data rather than having to pull it all out of Postgres. So Postgres is still necessary for the actual work that the Dagster product needs to do, but Kafka gives us this way of hooking into that event stream without having to bother our Postgres database.
And another question before we start digging into the pipeline itself.
Yeah.
Can you elaborate a little bit on why you chose to go with Flink versus we have some example Dagster code where you're using sensors and you have multiple sensors all pulling a Kafka topic and managing the cursor for you. And that would be a more traditional like streaming approach to this, where with Flink, we're like offloading that streaming to a dedicated tool and doing batch still on the Dagster side of things. And there are pros and cons to that. And I was just hoping you could maybe elaborate.
Totally. I think one of the things was just like persistence of data was one thing that I was thinking about. Like I just wanted our event log data in a place that we could easily get to it, Snowflake or not. It was really hard to access this data from Postgres, just pulling it out the way that we were pulling it out, right? So Flink made it easy for us to just be like, hey, let's land this data in S3 and then we can do whatever the heck we want with it. There probably will come a day where we want that data in more real time in Snowflake, and we'll incorporate something like Snowpipe or whatever to pull that data in a more real time manner. But for now, it was really just about, we need this data out of Postgres and in some format that we can more easily access it and access it quickly and broadly. And Flink was a good candidate for that. You could use a tool like Firehose to do something similar. Our engineering team, our platform team, was already setting up a Kubernetes cluster that had Kafka set up on it. And I think most of our team was familiar with how to use Flink. So it was easy to stand up. We could just put it in the same service or the same K8s cluster as a service and just hook them together, and we were good to go. So it was mostly a matter of convenience and wanting to persist that data somewhere outside of Snowflake, so we had it for the long term.
Gotcha. Yeah, and I guess replicating that to an S3 bucket is really nice. For the Kafka stream only has a certain retention window depending on how you configure it. So when you get all the data in one location, if you were to somehow mess up your data warehouse, you could always go back and repopulate those
Yeah.
tables.
Yeah, something I'm like trying to think about more as we like mature this data platform a little bit is like mean time to recovery.
Mm.
And it's just, if we just throw all this stuff directly into Snowflake, if something horrible were to happen and Noonan drop our database or something like that, we would be in a lot of trouble. But keeping it in S3 gives us a little bit of redundancy at least.
Cool. Yeah, we have a lot more questions, but I think we can dig into the pipeline now and then we'll get back to them.
Yeah, that sounds good. It should be a pretty quick walkthrough, and then we can talk through questions for sure. So I'll give you a brief little overview of what this pipeline looks like in Dagster. This asset here, first of all, is that zoomed in enough? Can you guys see?
Yeah, it looks great.
Beautiful. This asset here just represents that Flink writing process, right? This allows us to ping that S3 bucket to make sure the data is actually landing. We've set up asset checks on that asset to make sure that the data is actually landing in the right amount of time. You'll notice that this pipeline is currently sitting in a branch. As I mentioned, we're using a branch deployment here to make sure that we're not breaking anything in prod, right? This is still a very experimental pipeline that we're still testing out. So we've got this running in a branch deployment that keeps things from breaking too much stuff in prod. So that's the Flink asset here that's writing data to S3. This is that Snowflake stage. Again, remember we built that with components. On that first run of that asset, it'll create the Snowflake stage itself. On subsequent materializations, it's just going to refresh that stage and pull the data in from S3. And then downstream of that, we've got this external table. Again, external table is really just an interface on that stage, right? It allows us to easily select like we would from a table. And it works similarly. On that first materialization, create the table. On subsequent materializations, we're going to refresh that table so that we get all the new data that we pulled in from the last execution of the upstream assets. And then a little bit further downstream, we just have a DBT model thrown in on top of that. Very, very simple. Select from that external table. Just give me all of the data from that upstream external table. So very simple pipeline, right? As it should be. There's nothing crazy going on here. But yeah, and again, if you guys have any questions about this pipeline, just let me know. I want to dive a little bit more deeply into the actual Flink code here. Again, nothing wild happening in this Flink. Oh, sorry, Colton, did you have something?
I was just going to say, and somebody was just asking about how we are partitioning this data coming from Flink, and this will answer that question. You'll be able to see it on line 43.
Absolutely, yes. Basically, this is all the code that sort of represents that Flink process, right? So basically, from here to here, we're just connecting to Kafka, right? We're setting up the link from Flink to our Kafka service. And then below, we're defining how we want to write that data out into S3, right? We give it a path, we tell it how to encode it, and then as the person asked in the Q&A, we tell it how we want to partition that data, right? We are time partitioning this data by hour, right? And now, like I mentioned, when that new hour bucket hits, that sensor gets triggered in Dagster, it refreshes that external stage that's connected to the S3 bucket, and we just pull in that latest hour's worth of data. And that's all that's really happening in this Flink pipeline, right? We're just pulling in that data that's connected to that Kafka stream and writing it to S3.
And this is the one that's like 24/7 running in a pod on Kubernetes.
That's exactly right, Colton. Yeah, so we had I'm 99% sure it's running in the same K8s cluster as our Kafka stream.
Okay.
And again, just writing it to S3, and it's constantly online. Last, just a little thing I wanted to show is the sensor. There's a lot of code going on here, but effectively all that we're doing is hitting that S3 bucket every 5 minutes. We could probably decrease the sensor time here, but effectively we're just pinging that bucket to see when did a new directory land in that bucket. If so, let's trigger runs right here. We're triggering a run request that materializes all those downstream Flink assets. That'll refresh that Snowflake stage. That'll refresh that Snowflake external table. What this represents, that's that sensor that's running constantly and checking that S3 bucket.
Can we actually elaborate on this one a little bit more? Because it is a lot of code.
Yeah, it is. Sorry, go ahead.
I was going to say, how are we... Data is arriving in these different like folders at a certain time. How are we synchronizing like our polling sensor? Or just can you elaborate a little bit more on that code for detecting that changes have occurred?
Yeah, so it's not terribly complicated right now. So effectively what I'm doing is we got this data partitioned as year, month, day, hour, right? We can, my assumption was we can assume that the data will never be more than like a month out of date, right? So I am having this sensor check the current month and the last month in case we're like, say it's August 1st, we want to also check, maybe it's September 31st or something like that. We want to check like the last 2 months worth of those directories. There's only going to be at most like 60 subdirectories within the 2-month directories there. And we just look to see, hey, what was the last directory by time that landed within those paths? So again, not really that complicated. We're just doing like a directory listing of those 2-month directories to see, okay, all of September has been filled up. Great, that looks good. Looks like our cursor says August 24th. We've got a new directory in there that says August 25th. Let's trigger a run. Let's refresh that downstream external stage, and let's refresh that downstream external table. So again, nothing terribly complicated here. We just got that sensor checking to see what was the latest directory that landed within the last month or two.
I see. So do we have an overlap in this window where we're checking things?
That's right. Yeah. So like mostly just out of an abundance of caution for the beginning of a month. In case for some reason the stream is like a few days out of date at the beginning of August, we probably should also check September. Or I'm sorry, we should probably also check July.
Yeah.
That's the idea. So that's the sensor. Are there any more questions about the sensor stuff, Colton?
Maybe not specifically. So yeah, we can keep going and then we'll talk more about the questions in a bit.
Yeah, I've just got one more little thing on components. I just wanted to show off this Snowflake components object that we've built here, right? You'll notice basically all of the parameters from here up, if you were to go look up how to build a Snowflake stage, it's going to look very similar to what you see here, right? Where you define the name of it, where it's going to go, you're building a stage, what role is going to build that thing, where you're pulling it from, storage integration, all that stuff, right? And then we define some Dagster specific attributes, give it a description, condition, some dependencies. And again, this will create that Snowflake object in Dagster where on the first run, we're going to materialize it. We're going to build that actual stage or that table. And then on subsequent runs, it's going to refresh that stage or that table. And like we all this is done under the hood, right? There's a Dagster component class out there that handles all of this. All I had to do was write the YAML. I had already built this forever ago for a separate project, and it was really easy to just incrementally add a couple of new Snowflake objects, and we were off to the races. This was actually probably the easiest part of this pipeline was throwing in these components.
I guess we should call out, this might be some people's first time seeing a component. Yeah. Components are a framework in Dagster, like an abstraction framework, a DSL, on top of your definition. So your definition can be an asset, a job, a schedule, things like that. And we have a framework called components that allows you to either use YAML or Python, like a factory pattern in a way, but to more easily just create reusable code. So this is an example of YAML usage of this component that Nick made a while back.
That's right. I think of it as like a YAML front end rather than thinking about all this Python boil. Think about, for any of you who have used like a Snowflake Python connector or something, think about how much code you had to write to like connect to Snowflake, set up the actual creation of the object itself, then on subsequent materializations, refresh that object, right? Rather than do that every single time you build that asset, let's abstract that away a little bit. Let's build this component like Colton was talking about. And then every time we want to add a new one, it's just this YAML front end. I'm simply just defining the thing that I want to build, and Dagster components will build it for me. That's the idea. So that's really the end of my content here. I'm sure it seems like we have a few more questions and stuff. Colton, Noonan, is that about right?
Oh yeah, we definitely have some questions to go through.
Cool. Let's do it.
Cool. Do you want to rattle them off, Alex?
Yeah. I will add the first question. Here we go. Yeah. So, again, sorry in advance for any mispronunciations. So Ijtaba asked, are there any plans to improve the capabilities of Dagster sensors to subscribe to events-based triggers rather than poll, like using like pub sub systems or message queues? And this is like something that us as developer advocates, we've often like pushed product and engineering about. But from what I understand, I don't know if there's anything in the short-term roadmap about this, because to architecturally like change Dagster to allow that would be like a pretty heavy lift. But I know if it's something that's like important to you or like a blocking use case, if you bring it up to us, we will like keep on escalating it to keep its priority up.
I would also say this is something, I think we were just talking about this the other day before the presentation, where I was talking with somebody internally about how it would be cool to be able to do this, especially now that this is our sort of first internal use case for streaming. I think we can advocate for this a little bit better. And like now we have a real world situation where like it would be really nice to have some sort of event-based trigger for all of this. So that's a great question and something I've been thinking about as well.
And the next question from Zach Romer, friend of the show, is Kafka consuming Postgres CDC WAL, or is there something along those lines, or events placed in Postgres and Kafka concurrently?
I believe they are. That's a good question. I believe they are placed in Postgres and Kafka concurrently right now, but eventually Kafka is going to be the sort of source of truth of these events. It's going to collect the events and land them in Postgres. At least that's the idea that has been explained to me. It's not using, I don't believe it's using CDC or the write-ahead log right now, no.
Okay. And then we have a question here from Graham on how often do you run your DBT models?
It depends. We have a nightly run that gets triggered like every night around midnight. That's just like table stakes. That has to happen just to keep data updated. But there are some pipelines that we run more frequently. We have some data going into our CRM or like Salesforce and HubSpot, where that data needs to be updated a little bit more regularly so that our people on the marketing side and our people on the sales side have a little bit more real-time data. So I think those pipelines run hourly. That's a subset of our DBT models. But Dagster makes it easy for us to subset those, and we'll run a nightly batch of all of the DBT models, and then on an hourly basis, we'll just run a subset that updates the stuff that people really need quickly. So to answer your question, it depends. Just certain stuff's more important than others for real time.
Awesome. And then we have a question from Bernard over here. I'm busy implementing the event log backend using ClickHouse instead of the Postgres OSS version. Wonder if it might have broader community appeal. And I will say, Bernard, if you have like a solution that works well for you and solves problems, the chances are that there's some other Dagster user out there running into the same thing. If you want to share that with the community, that would be great. We can throw it in our awesome Dagster repo and elevate it from our side as developer advocates. You can DM me on the community Slack if you want to get that going. And then we have a question here from Brandon. List files in S3 can be slow in my experience. How are you handling the S3 buckets listing with all those files?
We are not listing all of the files. This is actually, that's a great question. We are not only listing subdirectories within a directory. So like, for example, let's say we're listing the stuff for the August month, right? At most, we are listing how many days are there in August? 31? I don't know. We are listing the 30 to 31 files that will be in that August directory, rather than all of those downstream, like full paths to the Parquet files that are all the way down in those hourly directories. So for a given month, just tell me how many days or how many hours, even if we go down to the hourly, tell me how many hours are in a given day. At most, we're going to have 24 files in there. Yeah, to your point, pretty slow. And it's still not crazy fast, right? Because we do have to connect to S3. We do have to like actually list those objects, but it's not that bad, especially since we're not looking at those full Parquet paths.
Yeah, and I think a lot of that has to do also with the partitioning scheme of the Flink data going to S3, where it is already being batched a little bit so that there aren't thousands of files. And then pairing that with using the prefix when you're listing files, using like the Boto3 client.
Yes.
Instead of listing all the files and then filtering it in Python, you want to provide the prefix so it's filtered on the AWS side of things.
That's right. We give it as much as we can to filter, to pre-filter beforehand, so that it doesn't have to go through the whole year's worth of data or 2 years worth of data.
Awesome. All right, and then a question from Steve here. When is the right point to consider Kafka and Flink? Have got away with using async ClickHouse insert for events or WAL-based CDC with PeerDB from PG into ClickHouse. What kind of volumes do you need to get to where the overhead of Kafka and Flink becomes worth it?
Yeah,
I really like this question.
it's a good question. For us, I was starting to get concerned with, like I said, that always on polling process that we were doing. We were just pulling in everything that happened since the last run. I was starting to get concerned that we were running close to the time for that pipeline to execute was going to take longer than the actual interval at which we were kicking off that pipeline, right? So if we're kicking it off every 5 minutes, I was concerned that pipeline execution was going to start running longer than 5 minutes, and now we're falling behind. So in our case, that was my concern. And also, you mentioned the write-ahead log and CDC stuff. That was a little bit more of a challenge for us from a working with our infrastructure team and our platform team. Like, that was going to be a little bit bigger of an ask to set up CDC. It requires certain permissions and a lot of work to get that stood up. But they were already working on the Kafka stream and the Kafka producer at the time. And I thought, what a great thing to take advantage of to pull that load off of the Postgres database. It was actually being built for our Insights product, but I wanted to start using it for our data product. But to answer your question, it was just I saw the current solution was beginning to outrun the needs that we had to get that data in at a requisite amount of time.
Yeah, it was two birds with one stone moment where we didn't need to use Kafka, but they were already doing it on the application side. So it just made sense to migrate our ingestion to use it. But you could probably get away with using the write-ahead log like almost forever.
Totally.
As long as you make sure you're ingesting that log fast enough so it doesn't take up disk space and run out of memory on your server running the database, you should be good.
Yeah, I don't even think it was like my first thought was like, oh, we're going to run out of time. We need to use Kafka. It was like, I would have been fine with any solution that allowed us to better incrementally pull that data in. It's just like Colton said, it was pretty opportunistic that Kafka became available as a way of processing these events, and it worked out really well for us.
Amazing. And then Bernard has another question. How are events emitted to end users in the Dagster UI in absence of a SQL interface? Is this handled with Flink?
That's a good question. I don't exactly know how we're doing real-time updating in the Dagster UI using the event data from Postgres. That's probably a better question for our front-end team. I don't know how they do the magic they do.
I saw a demo. I don't know if it actually ended up in the product where like the front-end team was reading Kafka events directly from the UI. Whether or not that's how they're actually doing it, I don't know. They could be doing some kind of batching on the server side and exposing that as a GraphQL endpoint, probably more realistically.
They're madmen over there.
And then Sterling has this question. How do you ever need to reconcile the Kafka events with the Postgres data events? In other words, I suppose it's possible for Kafka to miss events. And do you just ignore those?
This is something we're thinking about. No, I wouldn't want to ignore them. I think there probably will be some process where maybe we do a bigger batch of our Postgres data. I don't know how that's going to work. That's a great question, actually, Sterling, because there is a chance like Kafka could go offline or just something happens and it misses an event or two. We want to be able to reconcile that data in Postgres because, like we said, it's very important data powering billing and our analytics. So I'm thinking about that right now, some way of reconciling our Postgres data with the Kafka stream. But if Kafka ends up becoming the source of our Postgres data, then I'll feel a lot more confident about it, and I won't be as concerned about reconciling those two because it'll be pulling from the same source we are.
And Kafka also guarantees at least once delivery.
Yeah.
So there are some like deliverability guarantees of that stream, but there are still points where we can lose messages for sure when we're using Flink.
Maybe the event just doesn't get published to Kafka for whatever reason, and then you lose it. But it does get sent to Postgres for, again, whatever reason.
All right, and then Stephen has this question. I'm familiar with Kafka producers, consumers dealing with events in real time. Nick mentioned about batching up records into Parquet files. Is the batching getting done by Flink?
That's correct. Yeah, Flink is doing the work of consuming those events from Kafka and then writing them into Parquet files in S3. I'd recommend like looking into the Flink documentation and checking out their, I think it's called the file sync API. But that's correct. Flink is doing the actual file processing piece of this pipeline.
Awesome. And then Eloy asked, does the sensor trigger a run with every single file that it runs, or does it only do when a new folder is created?
That's a good question. So we can do it however we want to. If a new file arrives, we could do it that way. The way I've chosen to do it for now, just because we don't need this data in real time, is just when a new hourly batch finishes, we kick off the pipeline. The sensor triggers a run, I should say. So we could have it so that it's like, hey, every time a new Parquet file lands in S3, kick off the sensor run. But for now, we don't need it that fast. We just need an hourly job that pulls in the event data every hour, and we're fine with that lag. But yeah, to answer your question, we wait for an hourly directory to complete, sensor triggers, boom.
All right, and then Sean asked, just to check my understanding, threateningly, Dagster can be used to monitor the health of and or react to the outputs of streaming systems, but can't be used to orchestrate streaming pipelines yet.
Go ahead, Alex. I'll let you talk.
Yeah, I'd say that's an accurate understanding. But I think where Dagster can help you is if you have streaming as part of your data platform, you can observe like where the end products land that you can then incorporate into your like batch processing or even like event driven with declarative automation or sensors. Because oftentimes, at least in my experience at most organizations, you don't really need that like real-time data if you're just doing like analytics with dashboarding, because are you really going to make a better decision with a dashboard that is 2 minutes up to date or 2 hours up to date? Of course, when it comes to alertings and on the application side of things, that like streaming real-time events is important, but that's just a limitation of Dagster, I'd say.
And I would also say, I don't know, because I was wondering the same, you said it was Sean. I was wondering the same thing, Sean. Like, but then I thought to myself, like, what would that even look like if Dagster were orchestrating a streaming pipeline? Like, to me, the whole point of a streaming pipeline is that it just sits there and pulls in data as it comes in and lands it somewhere. There's no, like, the best thing that I can imagine an orchestrator does in that situation is tells me that the streaming process is doing a good job. And so I think there are things that Dagster could do eventually where we're better monitoring those streaming assets, those things that are doing the real-time processing. But I don't even know what the world would look like if Dagster were actually controlling those streaming processes. I think that would look like a bit of a different product than what we have right now. I could be wrong, but that was just as I was thinking about it myself, I had the same thought.
Amazing. Yeah, great question, Sean.
Great question.
And then Jordy asked, I've seen performance issues with external tables compared to regular tables in Snowflake. Have you experienced something similar? And why not go with iceberg tables instead of external tables?
You could. This was just what I'm familiar with. I haven't noticed any real performance issues on my end, especially if you partition the data correctly in Snowflake and let those external tables know, hey, here's how I'm planning to, generally speaking, here's how I'm planning to filter this data. External tables perform fine enough for me, at least, right? Like, for example, for the data that we're landing in here, I partition the data in Snowflake similarly to those partitions in S3. I say, hey, the hour that data landed in Snowflake is the field by which you should partition your external table, right? Because that's probably how I'm going to read that data into a DBT model downstream, assuming I'm going to do some sort of partitioning thing or some incremental load. So that's how I think about it. You could use Iceberg. I haven't really dove too far into the Iceberg space, but external tables is what I was familiar with. We could do certain things to partition that data to make those external tables more performant, and they haven't really caused us too much trouble as of yet. But good question. I agree. You could go that route.
Amazing. Great question.
Great question.
And then from Shira, if the streaming Kafka Flink pipeline fails, you'll get notified because the sensor fails to find the day's new folder. How would you handle it if it wasn't partitioned by day? Is a way for Dagster to monitor a streaming pipeline separately without relying on missing asset partitions?
This is something I was actually thinking about. To me, ideally, this was a bit of an issue just because connecting up to a Kubernetes cluster requires a little bit of work for us if we're not already sitting in the Kubernetes cluster. But I think ideally what we would do is we would hit the API for Flink or the API for Kafka directly to get whatever cursor that has last landed for either of those services rather than checking in the S3 bucket. Because I agree, this is like a proxy for, is Flink doing the job that it's supposed to be doing? The S3 files landing is the thing it's supposed to do, but it's not really like monitoring Flink directly, right? If it were up to me and something we're planning to do, I would hit the API for Flink directly and get some information from Flink about, hey, what was the last thing you processed? How's it looking? How many things did you process? All that kind of stuff, because all of that is available in the Flink REST API. So yes, to answer your question, like that's how I would want to do it, especially if we weren't partitioning on by day or by hour or something. But I would always want to partition it by some sort of time interval because it makes it easy for us to process downstream.
Yeah, and it's also possible to emit events to Dagster.
True.
So you could have some kind of callback hook on the Flink side of things that informs Dagster that new data has landed by using Dagster's GraphQL endpoint for launching a run.
That's a good point.
And then from Brandon, do you expose any metadata about the events in Dagster? For example, is there a level of data schema column lineage that you expose, or is it mainly just monitoring the movement of the data right now?
For the most part, it's movement of the data. In our DBT models, we automatically expose column information and a little bit of column metadata. And we could do that on that upstream data, but it's not something we've really dove into just yet. But to answer your question, yeah, we could do it, but we haven't done it just yet. It's mostly just like metadata about what was the last file that came in, or what was the last hour worth of data that you processed.
Amazing. And then somewhat related from Bharat, how do you handle schema drift?
That's a great question. For the most part, this event data is not going to change much. The schema of this event data doesn't move very much. The data is coming in as, actually, I don't think it's coming in as Parquet now that I think about it. It's coming in as unstructured JSON. So we can pull that unstructured JSON in, and what I do is I say, I only want these 5 fields, right? Let's say, like these 5 fields that I know are going to land every time. Some ID column, the name of the event that's being processed, the ID of the org. I don't know what I just did. There we go. The ID of the organization, et cetera, et cetera. But then all this other stuff that, to your point, could change at any given time, I'm going to just keep in an unstructured JSON, like what's the word I'm looking for? Like basically just a JSON object in my Snowflake table. That way, if I want that data, I can access it, but if it changes or there's some, like you said, some sort of schema change, it's not something I have to worry about it breaking my downstream data. But I can always access it if I need it. But to your point, that's a good question. If a new field gets added, then it's available in that JSON object and we can access it. And if it gets removed or changes or whatever, it's not something we have to be concerned about, but we can always pull it out of that JSON if we need it downstream.
Amazing. And then we got time for one more question. I just want to thank everybody for their great questions. There's been so many of them, but
this has been so much fun. I'm enjoying talking.
Yeah, we could have Roach here all day answering questions. From Magana here, has this pipeline been tested at scale or in prod? And what challenges did you come across that might be useful to share? Any issues that you guys are in the process of patching currently?
We're working on testing this at scale right now. Right now, we're just processing like a few sort of test orgs. And the biggest thing I'm noticing is like the refreshes are taking a little bit longer for Snowflake objects and stuff like that. Again, as long as we're like partitioning properly, it's not that big a deal. But biggest thing is now we've got to be a little bit more aware of the data coming into S3 and making sure that we're really keeping an eye to ensure that everything is landing in the way that we would expect. And that there's a real chance that, say, a rogue event comes at a later time, maybe it comes at a future hour just because of some random client time issue or something like that. We got to be a little bit more aware of that kind of stuff where data can get a little bit more fluky. Performance issues, I haven't noticed as much. Most of that has been handled thanks to our infrastructure and platform team giving the requisite resources to Flink and to Kafka. But I have noticed a little bit of time increase on refreshing those downstream Snowflake objects.
Amazing. And before we go, I want to say that we have an upcoming deep dive with a friend of the show and power Dagster user, Zach from Empirico. And he will be giving us an overview of how he does platform engineering and how he uses Dagster for that. And we may even hear from Zach about some of his components that he's got going. But if you've asked questions in the community chat, there's a chance that Zach has helped you. And I believe he's here right now. So register today. You won't want to miss that one. And of course, if you want to stay on top of all things Dagster, I would recommend you join our community Slack. And I just want to thank everybody for their great participation today. We had a great time answering your questions and talking about streaming and Dagster. So I look forward to seeing everybody in the next one. And I hope everybody has a great day and a bountiful harvest for the rest of fall.
This was so much fun. Thank you guys for having me.
Thanks, everyone.